Why is observation so confusing in quantum mechanics? Imagine watching a tiny particle dance around in a fog of possibilities. Now, picture that your act of watching actually changes what it does. That's the strange world of quantum mechanics. When we try to understand how tiny particles behave, things don't follow the rules we're used to in everyday life. In classical physics, observing something doesn't change it. But in quantum physics, just looking at a particle can make it jump into a specific state. This idea puzzles scientists because it's so different from what we see in the real world. The core of this confusion is the idea that particles can be in many states at once. Think of a can spinning so fast that it's both heads and tails at the same time. In quantum mechanics, particles can be in multiple places or have different energies all at once. This is called a superposition. The mathematical tool used to describe this is called a wave function. When we measure or observe the particle, the wave function suddenly collapses, and the particle chooses one specific state. But why does this collapse happen? That's a mystery because classical physics has no explanation for it. The uncertainty principle, made famous by Werner Heisenberg, adds to the confusion. It says that certain pairs of properties, like position and momentum, cannot both be known precisely at the same time. Early on, scientists thought this was just because measuring one property disturbed the other. But later, they found that this uncertainty is built into nature itself. It's not just a measurement problem but a fundamental feature of particles. Another puzzle is the Einstein-Podolsky-Rosen paradox, proposed in 1935. It questions whether quantum mechanics gives a complete picture of reality. It describes how two particles can become entangled, meaning their states are linked no matter how far apart they are. When you measure one, the other instantly changes, even if they are separated by large distances. This seems to break the idea that nothing can travel faster than light and challenges our ideas of cause and effect. People often think that observing something means a conscious person is involved. But in quantum mechanics, it's not about consciousness. It's about the physical interaction between the particle and the measuring device. When a photon hits a particle to observe it, that interaction changes the particle's state. The act of measurement is a physical process, not a mental one. A famous example that shows how weird this gets is Schrödinger's cat. Imagine a cat inside a box with a device that can kill it based on a quantum event. Until you open the box and look, the cat is both alive and dead at the same time. Only when you observe does the cat pick a single state. This thought experiment highlights how superpositions and measurement challenge our ideas of reality. So, why is observation so confusing in quantum mechanics? Because particles can be in many states at once. Measuring them causes a sudden change that we don't fully understand. Uncertainty is built into nature, not just caused by measuring. Entangled particles seem to communicate faster than light, defying classical ideas. And the act of observing is about physical interaction, not consciousness. These mysteries have pushed science to new frontiers and led to innovations like quantum computers and secure quantum communication. The strange behavior of tiny particles continues to challenge what we think is possible in our universe.